Hello again, my name is Amanda Pfeiffer. I am an education coordinator at the Canadian Light Source. Welcome to another video where we are interviewing different staff members across the facility. Today we have Gosia, who is a Beamline scientist, but before we get to that, we would like to acknowledge that the Canadian Light Source, which is in Saskatoon, Saskatchewan, is located on Treaty 6 land in the traditional territories of the Nehiyawak, Anishinaabe, Lakota, Dakota, and Nakota nations, and the homeland of the Métis. And as educators, we respect Indigenous ways of knowing and oral traditions. And throughout all the relationships with different classes and different educators, we are moving forward in a spirit of partnership, reconciliation, and collaboration. And we encourage you to take a moment, think about your own relationship with the land and Indigenous peoples. So with that, connecting to you from Saskatoon as well is Gosia, who's in the facility. So I'm going to hand it over to you to introduce yourself, tell us what your job title is, and yeah, where exactly are you?
Hello, everyone. I'm a senior scientist at Canadian Light Source. I'm a scientist responsible for the BioXAS sector, which is composed of 3 different beamlines. Right now, we are on the BioXAS Imaging beamline, and this is the end hatch. So this is the hatch where scientists come and they mount their samples and they conduct their experiments.
Cool. So can you tell us a little bit, what is a beamline scientist? What do you do, or what are some of the tasks you do in a day?
So that depends a little bit, I guess, when you start at CLS and the stage of the beamline that you are responsible for. So for example, for me, when I started, BioXAS was still in the construction. So lots of my tasks actually involved project management, purchasing big equipment, specifying this equipment, and actually like building itself, it's mostly done, of course, by the technical staff and engineering staff, but you are there basically to test the equipment once it's built. So lots of my time at CLS, since I joined, was actually spent on testing new equipment and bringing everything to the state that was usable by the scientist coming from the outside. And this is basically, I'm very happy this is done now, and we are moving to a different stage when we can finally start accepting scientists and we can provide the beam to them, and then we can help them also to measure their samples.
That's really interesting. I don't know if a lot of students get that idea that when they're interacting with different scientists, the beamlines are already built, and so they're just conducting research, but not so in your case. So that's really interesting, how you helped develop and build the beamline that you're standing in front of. So what does your beamline, what's some of the research that it does focus on or is able to look at?
So BioXAS imaging specifically, because we also have BioXAS spectroscopy, and this one actually will provide slightly different information. However, BioXAS imaging, we take samples that could be plants or could be actually animal tissues, could be various things that that has some sort of special structure, and you would like to connect that special structure with elemental distributions. So for example, if we have scientists coming with a brain, human brain even, coming from a patient that died of multiple sclerosis, for example, then we can look at the slices of brain, and then we can correlate the structures that we can see with elements accumulated in certain areas. And then this can actually shed some light on possible etiology of the disease, for example. We can also look at plants. Some plants are actually hyperaccumulators. They can accumulate lots of different elements, for example, cadmium or selenium. However, scientists are interested in where exactly within the plant this accumulation is happening. And this is where BioXAS imaging can help, because it can actually provide that visual information. What you will see basically an image of a plant, And then you can see distribution of calcium, zinc, but also of the selenium or cadmium.
That's fascinating. That like a lot of different applications for an imaging beamline.
Yeah.
Switching gears a little bit, can you tell us a little bit about your career path? How did you get to working at CLS?
So as you may guess, from my accent, I'm not originally from Canada. I was born in Poland and I actually did my PhD. So I started, of course, with bachelor, master, and then PhD degree in physics in Poland. And then as a part of my training, still during PhD, I went for a 1-year fellowship to Germany, and this is basically that was my first encounter with the synchrotron. So I was actually working at the synchrotron there, learning about the technique that I used for during my PhD. And this is basically how I got interested in synchrotrons and specifically in a technique that it's called X-ray absorption spectroscopy. I went back to Poland, I finished my PhD, and then somewhere along the way, I realized that I really enjoy doing research and I would like to stay involved in science. So as part of that, usually there is a postdoctoral training. So I did my postdoc actually at the same laboratory in Germany where I did my training during my PhD. And then I came to Canada to actually continue my research and my postdoctoral fellowship here in Saskatoon, actually at the University of Saskatchewan. And then eventually, I actually applied for a job here at the Canadian Light Source when there was opening for a scientist. New beamline BioXAS was in the process of construction and they were looking for somebody to help and I applied. So this is how I got actually to Canadian Light Source.
Cool. So what got you originally interested in science?
I think I was always interested a little bit in physics. Physics was something that I really enjoyed. I had great physics teachers when I was still like in, a middle school and then in high school as well. And I think that's basically, that first teacher from middle school, I think he actually was the one that sparked my interest. I think it was like an eye-opening that physics can actually explain so many phenomena, natural phenomena that we can see. And I remember that moment, I remember that moment realizing that this is so cool, that you can actually have explanation. And I think just because, I was lucky and I really got good mentoring in my high school. I was considering actually doing a medical degree. In Poland, you can actually do medical degree straight after grade 12. And I was preparing for an entry exam, but then along the way, that physics was still somewhere back of my mind. And I actually changed my mind. I decided to follow my heart, I would say. I realized that I actually don't want to be a doctor. I want to be a physicist. So I started my studies, but I wasn't really thinking about doing PhD. It's in Poland, we actually, at that time, we don't do bachelor, we go straight into a master program. So it's a 5-year program that ends with a master thesis. And then I think 4th or 5th year, in my studies, when I started working on my project, and it was very interdisciplinary project, because I had to actually harvest cells from red femurs and then culture them, expose them to actually to gallium compound that was used in cancer treatment. And that was really something, that showed me what potentially research is and what it means to me, that I had so much actually fun, learning new things, culturing those cells. This is basically when I decided, that I would like to pursue. I would like to continue and, get into graduate studies.
That's such a neat and interesting story. I didn't realize that Poland had slightly different setup in terms of doing the
Yeah.
master's for 5 years.
I think it's different now. It may be actually more closer to a Canadian system, so actually with a bachelor and then, master being part of graduate studies.
Okay. So next question we have kind of relates to safety as you yourself are standing in the end station. And I know that's typically a question we get with students is, are there any kind of hazards or safety concerns that you have to deal with your work, and how do you handle them?
I have to say, I always feel very safe at CLS when I'm working here. I can also mention, that I was pregnant with my second child, my daughter, while actually commissioning the beamline. And, we were actually doing also radiation tests. So everything, was fine. I never felt like, my safety was at risk. We have really good, health and safety department that really takes care and have certain procedures. So we are in the hatch. That hatch has quite a lot of, safety solutions. So basically, when you mount the sample, you really have to look around when you leave. You have to press 2 buttons on both sides to make sure you're not leaving nobody behind. And then you close the door. Everything is enclosed and lined with lead. So there is no radiation coming outside. So we are making sure that nobody is here when we let the beam in. And this is a very safe system. And then when we are outside, that's typical procedure. When you build a new beamline, you have to actually test if there's any radiation escaping. There may be some cracks somewhere, some seams. So this is all tested very rigidly, and then there is also, we are also looking at the worst case scenarios always in situations like this. So it's very, very safe when you are outside. And then we are also making sure that nobody's left behind, of course, when we are doing the experiment.
Absolutely. Safety top priority at CLS. I know I've said those words multiple times. So kind of stemming from that, thinking now about stress, is there any stress that comes with your job, and how do you handle or cope with that stress? And that can be, especially now when we're working from home and having to deal with the pandemic issues, how do you handle stress?
It's, the stress is it's part of our life. So it's part, of me being, a scientist and, having big responsibilities. I'm really lucky. I have a great team of people at CLS that I work with, so when I do enjoy coming to work, and having that sort of not just a work type relationship, but, really, chatting with people, checking with them. I have some people, that are my direct reports. So I am responsible for, their well-being when they are at CLS too. So I always, try to make them feel less stress about the workplace. I do love Pilates, and I think, any type of physical exercise, it could be even just walking. It's very good when you are stressed. And I had multiple times, that I would actually, when I was really stressed at CLS, I would actually go for a walk, even outside CLS, or, if it's winter -40 Saskatoon, then you just go around the ring. And it really helps. It definitely helps just to have some, physical movement. And then, always having, something, thinking, in the end, at the end of the day, what's really important for you in life, if it's family, if it's your pets, just, something that you have outside of work that you can also focus on a little bit and give your mind a rest. I think that's the problem with lots of scientists, that we tend to bring work home because it's always with us. We keep thinking about, things that either bother us or are quite fascinating. But, I have kids at home, small kids at home. So sort of naturally, when I come back home, I have to fall into a slightly different way of thinking.
Yeah, that's a really good message. What's your favorite part of your job?
Yeah, it's a good question. I think lots of things, definitely, testing when we were commissioning the beamline. It was very challenging. I was learning lots of new things. I had to educate myself about certain ways of doing commissioning, of even some programs that we use to actually model how the beamline should perform. So I really enjoyed it. I enjoyed working with my colleague Ibi. She's associate scientist on BioXAS Imaging. So we would do usually commissioning together before COVID. And I really enjoyed, those discussions that we had, like, we are planning what we are going to do, some experiments. The most exciting part, definitely was when we mount our first sample and that zebrafish head, and we actually got such a nice image. That was very exciting, for sure. But I think, overall, I do enjoy working with people. I also enjoy lots working with high school students. I have to mention this because, that's, I think it reminds me a little bit, when I was a high school student, and it reminds me, that passion that I had as well. So that's the part that I like at CLS.
Yes, and we definitely like it when you are contributing, helping out, mentoring for our education programs. It's such a rewarding and valuable experience for them, and especially when you get to talk to them and not only just share what you know, but you get to just help them develop and grow is pretty rewarding. So yeah, I guess maybe just to kind of wrap it up with one more question. What kind of advice do you give high school students as they're thinking about their future careers?
I think it's important still, I know that people will look at, a job market, what in the future will be important. I would still, suggest to really try to find, what really sparks your interest, and, find profession that it will be part, that spark will be part of it. Because it's very hard, sometimes I have hard moments here, but what keeps me going, is still that spark that I had, when I was in the middle school, actually. So really, but it does take some, trying. Trying is great, because I also didn't really know at the beginning what I want to do. Physics was interesting, but physics is such a broad subject. And, in the end, I ended up doing very interdisciplinary work, that has a little bit of physics and chemistry and biology. But I think just, spending some time on trying, thinking what's really interests you. I think what's also important to you, what are your values, and what's sort of your purpose in life, like what's really it's important to you. And I think basically just use this knowledge and try something. And I think it's important not to give up, because it is hard. It's, for me, it was also not. It sounds very easy when I was saying, oh, I went here and then I went there, but I mean, there is some struggle. You have to apply for jobs you don't know, especially when you are at the postdoctoral training. It's always term contract, so there is some stress, but you just keep trying, and eventually I think you find your niche, you find something that you enjoy and you are good at.
Yep, that is definitely a really good place to end on. So thank you so much for taking the time to meet and share your knowledge and wisdom. And yeah, we look forward to collaborating with you again.
Thank you, Amanda, and thank you, everyone.